It is a pleasure that you could join us today for the webinar on Manufacturing, Production, Machinery, Performance Engineering, Simcenter. The new era of industrial machinery with Simcenter requires a new engineering approach. With Siemens Digital Industry Software, let's dive deeper into understanding how advanced simulation and test solutions can help us engineer, simulate, and virtually commission advanced machines from concept to validation to in-service deployment. Before I invite today's speaker, let me take you through our upcoming event, which is 3i Expo, scheduled for 20 and 21st of May at Nehru Center in Mumbai. IPF, Industrial Product Finder magazine, launched in 1972, celebrates 50 years this year. It is one of the oldest and most trusted brands in the industrial publication space and a go-to magazine for several decision makers. IPF Online, the digital presence launched recently, has a wide digital presence and brings to you all industry updates at a click of a button. One of our latest offerings is iNow, that is IPF on WhatsApp. Just give a missed call to the number that you can see on your screen and stay updated with the latest industry news. Some of our other offerings include expos, conferences, seminars, and awards. Digitalization is changing how products are designed, fabricated, used, and serviced. Just as it's transforming operations process, energy footprint, and factors and supply chain. With 3i Expo, we envisage to bring all the stakeholders contributing to Industry 4.0 and digital transformation to the same platform. Our motive behind this event is to create a platform where we can learn, network with the industry influencers as we strategize to optimize, modernize, and innovate. Some of our partners for the event. We do have support from the MSME enterprise, and we have 80 to 100% subsidy on the stand spaces that you can book at the event. MIDC is the presenting sponsor. The focus areas or the focus sectors of this event range from aerospace, defense to toys. The Sorry for the interruption. There is some technical error on my side, and just give me one more minute to get back. The chief guest for the event would be Shri Som Prakash Ji, who's the Honorable Minister of State for Commerce and Industry at Government of India. Guest of honors for the event include Mr. P.M. Parlevar, Director, MSME Development Institute, and Mr. Sanjay Bhatia. The keynote speakers at the event, other panel speakers, we will also host the 6th edition of IPF Industrial Excellence Awards. We recently concluded the jury, and these are the categories in which the awards will be presented. The conference agenda includes very interesting panel discussions. The future of manufacturing and Industry 4.0 will talk about capital costs versus profitability. We will have a validation session to understand how automation, what are the advantages, challenges, and solutions. On the second day, we will have a policy intervention session where we will talk about making India the next manufacturing hub and conclude with the 6th IPF Industrial Excellence Awards. We've been doing conference webinar series and roundtables across India. You can grab a screenshot and connect with Mr. Satish Menon, the Vice President Events, if you have any further queries on this. With this, I now introduce the speaker for today, Mr. Sushil Samuel, to tell us more about manufacturing, production, machinery, performance engineering. Sushil's experience encompasses design and engineering simulation across all manufacturing industries. He has over 10 years of simulation experience and has successfully delivered several projects. May I now please invite Mr. Sushil Samuel to join us.
Thank you, Prashali, for that introduction. Let me just bring up my screen. Right, so we are here today to discuss the manufacturing and production machinery performance engineering. Now, I realize that most of you all have probably had a heavy lunch, and a little too much talking will put everyone to sleep. So I'll keep it more interactive. I have videos. I'll keep it short and sweet, and that way we can wind this up as quickly as possible. Now, the focus of this entire presentation is all about you and how you can make your engineers discover better designs faster, basically driving product innovation. Now, I know your time is very valuable, so let's get started right away.
In today's competitive environment, getting better products to market faster is not just desirable, it's essential. Manufacturers need to meet tight development schedules and budgets. While competing for a customer's interest and loyalty, innovation and superior product performance are key. On top of that, many products have evolved into intelligent systems, requiring a radical change in the entire engineering process to allow for systems-driven product development. With the Simcenter portfolio, Siemens PLM software helps leading automotive companies to develop better performing and safer cars. We help the major aircraft manufacturers engineer the airplanes you travel in. We help the telecom industry by testing the satellites that support the wireless telecom revolution. We ensure better fuel economy, lower emissions, and increased performance for marine vessels. We contribute to more efficient and safer processes in the oil and gas industry, and we help thousands of other customers in other advanced manufacturing industries to create brand value. In this hyper-competitive age, The ability to create innovative designs that address specific market needs and getting them to market faster than anyone else are key factors to sustained growth and long-term success. The Simcenter portfolio specifically addresses the engineering challenges associated with intelligent systems development. Our state-of-the-art software and hardware are applied to optimize critical engineering attributes, ranging from system dynamics, fluid and thermal performance, structural integrity and sound quality, to durability, safety, and power consumption. Our software, hardware, and services enable radical process change. Our simulation software and innovative testing systems support optimal decision-making all the way from initial concept to final delivery. We offer tailored software and information technology to support this integrated development process. Upfront analysis at the concept stage, virtual simulation to refine and optimize digital twins, and in-depth testing of a reduced number of physical prototypes. Combined with Simcenter, we provide the platform for a knowledge-based approach, where engineers can collaborate and share information across the extended enterprise.
Sorry, I think there was some glitch in the audio, but anyway, moving on to the next slide. So basically, Simcenter is how we go about performance engineering.
And throughout the entire process, our engineering experts team up with leading manufacturers worldwide to share our latest technology breakthroughs and improve their products and processes. By combining physics-based simulations with insights gained from data analytics, Simcenter solutions help optimize designs and deliver innovations faster and with greater confidence. We help companies deploy a new predictive engineering analytics approach in support of a closed-loop, systems-driven product development. All this enables our customers to deliver unrivaled product performance while significantly cutting time to market. It's moving away from the expensive and ineffective test, analyze, and fix approach to design right first time. For decades, thousands of engineers around the globe counted on us to develop their ideas into top-performing products, and they can keep counting on us for decades to come.
Right. So Simcenter is basically how we go about the entire performance engineering aspect of product performance. Now, let's say, what exactly is performance engineering? What we expect a product to do in the field? Is it going to be able to do that properly? Is it going to be able to do that reliably? Is it going to be able to do it safely? There are a lot of things that need to be validated before the product is put into the field to ensure that it functions as expected. All this in all the different domains, whether it's vibration, whether it is CFD, whether it's flow thermal, whether it's electromagnetics, microstructural level, everything is part of the performance engineering, which we will be getting into in more detail during the course of this presentation. Now, first things first, these are my coordinates. If you feel require any further information on anything that I'm going to show, I have a lot of case studies, but I will not be going into detail in each of them because there are a lot of people who will be interested in different case studies. So if there is one particular case study that does catch your eye, please do contact me and I will get back to you with more details on that particular thing. And in that particular industry, any more case studies that we have. What I'm showing currently is just a selection of case studies. You can take a screenshot of my coordinates if required. Now, moving on to the trends that we see in industrial machinery. One is consumer-driven customization. One is smart manufacturing and Industry 4.0, as Vrishali was talking about. New technologies and the entire digitalization thing now. Simulation and performance engineering is just one aspect of digitalization. There are multiple other aspects from the smart manufacturing aspect. There's the product lifecycle management aspect. There are multiple different aspects to digitalization. So all these different new technologies can come together to enhance the industrial machinery segment. And another big challenge that we all face is um, global competition at lower costs. We all know the company, I mean, the country that I'm talking about. They have a very lean business model. They have very lean business model, so they're able to deliver things at a fraction of the cost that we may be actually selling it at. So how do we combat that? All these things are challenges that we have to take into consideration. Now, in terms of consumer driven customization, just a minute. Okay. So machinery design trends can actually be summed up in one word: complexity. And a key part of that is coming from the Industry 4.0 initiative. Now, essentially, this means that companies need to manufacture with a decentralized autonomous machines that can communicate with one another and the products they are manufacturing so that the production can be optimized. Now, now, coupled with these is also the mounting end customer demand for customized products, which drives demand for customized machines. From a singular unique machine selector to the design and manufacture of personalized perfume bottles, this customization adds up to much more complexity. Then regarding smart manufacturing, uh, in this increasingly global manufacturing environment, threats from across the world or even a neighboring country are an everyday occurrence. The European Machinery Organization, SECIMO, points out that in just a few years, 80% of the manufacturers will have global operations versus just 50% today. And just looking at the latest numbers, you can see the global reach of machine tool producers. And finally, we have the regulatory pressures that are driving the future of machinery design, whether it is governmental or environmental, or just the aspect of customer opinion on the development of green machines. These requirements are not going to go away, and they have a huge impact on how machines are developed. Now, each of these factors has a major impact on the organization's bottom line one way or another. Whether it is the requirement to upgrade existing technologies, increase the R&D budgets, or maybe look at ways to reduce costs through design process, but without compromising on the quality. On the other hand, each one of these trends is also making innovation increasingly important to keep the competitive edge. So basically, the idea is disrupt or get disrupted. Now, the cost of status quo, I think this is one thing that a lot of people fail to take into consideration. Like, okay, today things are going well. Why do we need to change anything? Um, maybe things are going well. Maybe you don't need to change at all. That's the same thing Nokia and Hindustan Motors thought. Um, things are going well. We are the market leaders. Why do we need to change anything? Um, and then now where are they? The ambassador is nowhere to be seen. No, Nokia phones are nowhere to be seen. Basically, they didn't adapt when the market called for it. When people were moving to Android, at the time when I mean, Android, most people started shifting at the time of when it was in gingerbread. That time, Nokia had their Series 40 and Series 60 phones, which were, I'm sorry to say, but complete rubbish compared to the Android capabilities at that point. So uh, this is if the companies do not address the challenges they face today and adapt their product development process, over time, it will affect their bottom line. Now, digital transformation is the key to mastering today's challenges and unleashing innovation. Now, as you heard, even Vishali saying that digitalization is very, very important, and it is something that industry at large is adopting. So, in the in today's fast-moving market, the biggest challenge companies are facing is how to effectively handle all the disruption. That's the growing competition, the innovation of new technologies, and honestly, there are only two ways to succeed. Either they disrupt first, or if someone disrupts them, then they must make sure that they're able to respond very quickly. To keep this competitive edge, companies today need to make digitalization central in their product development process. This is key to keep up with our quickly evolving world. Otherwise, your products will be replaced with smarter, better, cheaper alternatives from your competitors. Again, I go back to the examples of Nokia phones and the Ambassador. The choice is very simple. Either innovate these highly complex products quickly or stagnate and risk losing business and market share. Now, this is basically a quote by the CEO of Accenture. Now, of the Fortune 500 companies, a little over half of them have disappeared since the year 2000, mainly because of digitalization. Now, people have started since 2000. People have started disrupting quite a bit, and if your company hasn't gone digital, if you're not able to respond quickly, then there's a very good chance you're going to get run out of business very, very quick.
Digitalization changes everything. The world around us is changing due to an exponential growth of technology. And digitalization benefits are not only reserved for the happy few bigger enterprises. I am here to tell you that it brings added value to a wide range of companies in various sizes. Every enterprise is unique, and so there is no one-size-fits-all solution. Market demands are changing rapidly. On average, we could say that there is a higher need for development speed, call it the from ID to shelf time, for flexibility as a result of the increased personalization of products, for quality as a key differentiator, and for efficiency, meaning energy, equipment, and resource efficiency. Let's have a look at a tangible example. This machine has been built by Delta Application Techniques. Its main task is to perform quality tests on bottles before filling them. The key performance indicator is simple: achieving the highest possible throughput rate. When introducing a completely new machine, manufacturers want to be sure that its design is feasible and performs its tasks, so they can validate the concepts they have in mind up front, together with their customers. This is a major differentiator in the pre-sales phase. The Siemens digital twin concept provides the answers to those challenges. A digital twin is essentially a digital copy of the machine. It is an intelligent and dynamic virtual model in which mechatronic and kinematics behavior is included. Most of the engineering tools incorporate simulation functions for validation purposes. However, connecting these tools with the automation software and controllers provides the real benefit. This approach reduces the need for physical prototypes significantly. Think about some of the things you can do virtually. You can reduce factory acceptance time through virtual commissioning. You can guarantee fast and accurate maintenance support. You can even start training operators before delivery. To improve an existing machine, we systematically look for the bottlenecks in the as-is configuration. Using a multi-physics model, alternative scenarios are explored to enhance performance. Physical testing is required in order to validate and improve the model and its parameters continuously. By the way, models are not only used during design, planning, and engineering phases. They are also of vital importance during operation and service. The digital twin touches the entire value chain and represents the product, production, and performance used for validation of the real-time machine. Critical production parameters and machine statuses can be managed in MindSphere, the Siemens cloud-based ecosystem, providing performance data and analytics. So, don't wait and implement now. Digitalization started yesterday.
So now, coming to the exact what we mean by the digital twin. So it basically we want to digitally capture all the phases of the product development process. Okay, now the first one is the ideation phase with a digital product that helps you digitally define or improve your design and analyze its performance. This is where we will be spending most of our time today. Then the next is the realization phase, with digital production to digitalize the manufacturing process of your product and anything used to produce it. So basically, you can virtually commission your entire manufacturing plant, the entire supply chain before you even go into actual production. And then there's the utilization phase, where you will digitally capture and relate all the elements of your product from design to manufacturing and to the actual product in use to ensure it performs as needed throughout its life. Now, this is actually the utilization of the product in the field. So as you saw in the video, we have Siemens has another product called MindSphere. So basically, that is used for industrial IO, industrial Internet of Things, and your products can actually communicate with the cloud, and you can get feedback on the usage of the product in the field, and use those metrics to calibrate your product design and your realization phase. So as you saw in the video, there's the product production and the performance. Now, as part of performance engineering, there are different areas that we need to look at. Now, let's focus in on this ideation phase. Now, that's where performance engineering plays its biggest role in the product development process, and we need to see how we need to evolve it to support the concept of a holistic digital twin. Now, first, it is clear from the trends today that today's companies are dealing with increasingly complex systems and technologies. So it is critical that they have a realistic representation of their product to give confidence in their designs and ensure that the design decisions are actually correct. If we can improve this confidence in both simulation and test data, we can reduce the need for over design, and that we can also reduce the end of cycle physical testing and reduce the number of field failures. All this leads to faster time to market and significant cost savings. In addition to that, having confidence and trust in simulation and test processes is also very, very critical to make real-time decisions based on feedback from the digital twin. Now, secondly, to support the digital twin, it is critical that performance engineering processes are not isolated and disconnected from the rest of your organization or the PLM process. We need to connect people, projects, and data to efficiently tackle the innovation of these very complex problems. If companies are able to reduce barriers and enable enterprise collaboration, they not only increase the process efficiency, but they also get a more holistic view to make the right decisions with all the stakeholders across the organization, like let's say quality or the costing departments. Everyone gets a view from the beginning of the process. So this way they're able to close the loop between requirements, design, and verification over the complete engineering cycle. Now, finally, having realistic and integrated processes and models today is not really enough. You also have to be able to deploy them so that they bring the necessary insight to make the design decisions and do it quickly. A key value of digital performance analysis is that it allows for quick and cost-effective evaluations of design changes. Now, very often we may want to try, like we were looking at multiple variants, right? So you want to evaluate multiple variants differently. So you need to be able to do that quickly. Now, a result of this is that in order to get the most benefit of your simulation tools, you need to be able to intelligently explore the design space to quickly understand design drivers, trade-offs, and to discover better designs. This, of course, means that we need to be able to interrogate the information from these hundreds of designs to make decisions. High-quality analytics as well as visualization on top of the simulation are also critical to make simulation usable and accessible. Now, these are the different stages of each of these realism thing. I won't go into those because I think they're fairly self-explanatory. And now, the backbone for all this needs to be a set of streamlined and automated workflows, consistent interfaces, and efficient processes that reduce engineering time and allow engineers to spend their time where it matters, which is innovating. So, by maturing your performance engineering practices in this way, you can ensure that you keep a competitive edge in today's fast-moving market because it leads to innovative solutions, brings products to market faster, and results in better, high-quality products It also reduces development costs and significantly increases your market agility in case you are disrupted first. So basically now you're able to engineer innovation. Now with this holistic digital twin, as I mentioned, all the different phases, that is the ideation, the production, and the performance in the field, all these different phases can talk to each other. And in that way, the designs continuously improve themselves. So let's say we know in the field that this particular component is vibrating too much and is likely to fail. We can change our design to ensure that the natural frequency is slightly modified. So resonance will not occur. And that way, we know that there's not going to be too much of an amplitude during vibration. So chances of failure are less. So this is something that we wouldn't have known if we didn't have the data from the field. So in that way, we strengthen the entire process, manufacturing, product, and the performance in the field. And all these things are connected and working together to continuously improve products and their production. Now, this is a video that showcases how Siemens tools, now not just simulation, but different tools like CAM, the NX CAD, multiple tools are leveraged by this company to fully implement a digital twin across the organization.
My name is Jan-Willem Ridderinghoff and I work for the engineering department of a company called PM Bearings. And at PM Bearings we make motion components, ranging from the single bearing components, linear bearings mostly, up to fully integrated motion systems. And we do that mainly for the industries in the semiconductor application and in the medical industry.
This person is from the R&D team.
Our customers are demanding very short time to market, and for that we need a really good efficiency in our way of working. So the Siemens software helps us with that, to get the product from design up to delivery in a really short cycle time. Yeah, the Siemens PLM software we are using are the Simcenter package. So we use that to combine all the different packages that we use, and those packages are the NX CAD environment. We also use the NX CAM environment, and we use the Simcenter environment to make all the analysis of the parts that we design.
GARS PLM Solutions is a platinum partner for Siemens PLM software, and our goal is to enable customers to make the best product by implementing the right software they need. Regarding the relationship with PM Bearings, it's a real strong partnership for several years already, and we use our expertise to help them implement the right software they need to digitalize their design, engineering and manufacturing process.
GARS PLM Solutions helps us with setting up our installed database and also with all the other applications. So we have a very tight collaboration with them.
Ik ben verantwoordelijk voor het omzetten van klantvragen, eisen, wensen naar een goed design. Ja, de uitdagingen zijn heel uiteenlopend. Dat kan zijn van hele hoge nauwkeurigheden tot omgevingen waar je aan moet denken, dus cleanroom-omgevingen of dat soort zaken. Maar het kan ook te maken hebben met bepaalde materialen die niet gebruikt mogen worden. Dan kun je denken aan niet-magnetisch of het moet opereren in ultra hoog vacuüm. Ja, om deze uitdagingen op te lossen gebruiken we NX CAD. Dit pakket gebruiken we om modellen uit te werken. Ja, hiermee kun je bepaalde doorsneden maken, je model goed analyseren, maar we gebruiken ze ook om werktekeningen te maken. Wat ik dagelijks gebruik is de interactie met Simcenter, zodat je altijd makkelijk bij je producten kunt. Een groot voordeel daarvan is dat je ook je attributes kunt vullen. Dus bij elk onderdeel kun je attributes aan het onderdeel hangen. Dat is een grote pre voor werkvoorbereiding.
I think the biggest challenge for me is to make accurate simulations in a short time frame. The difficulty with bearings regarding the stiffness, they're geometrically nonlinear. For example, if you push a roller into a track, the contact surface increases, which stiffens up the bearing. So taking this geometric nonlinearity into account, well, that is what I do with the software. There is no need to export the model to a separate FEA module. I can do all computations just within the Simcenter module.
Nou, we gebruiken hier NX CAM en dat helpt mij heel erg ter ondersteuning met alle features die erin zitten om tot een juiste oplossing te komen voor elk probleem. De belangrijkste feature op dit moment vind ik wel de 3D simulatie. Die is grafisch heel sterk. Elke fout komt heel duidelijk aan het licht en dat is wel echt een groot pluspunt. Het scheelt gewoon, ik denk 80% van de tijd.
What we achieve by using the software of Siemens is that we get the whole company connected to each other. Everybody benefits, for example, from using Teamcenter, so people can visualize the designs that our CAD engineers make. People can also get all the ordering information out of Teamcenter. The CAD engineer can directly get his CAD model to the CAE engineer, so he can make the analysis of the parts. Also can make adjustments to that if necessary and redo the analysis, and then feed that back to the CAD engineer again. And once we release the design, the CAM engineer can get it directly out of Teamcenter. He can make all the programs for the milling machines and send those directly to the machines. So in the end, we gain a lot of efficiency by using the whole Siemens package.
So basically that was a view of how Teamcenter, which is a PLM solution, connects everything, which is simulation, connects CAD, connects the CAM aspect, everything into one tool, so everyone can access it from different parts of the organization. So now we'll dive into the performance engineering aspect of the ideation phase. So here we'll get a closer look at the Simcenter portfolio of simulation tools which facilitate this. This is just a brief introduction. I'll get into more detail later.
Every innovation begins with a dream. But in this age of intelligent products, it's more difficult to get that dream off the ground. Engineering in this age requires a new approach, one that's more integrated and can better predict product performance. Introducing Simcenter from Siemens. Simcenter helps you create a digital twin that accurately simulates product performance from concept through end use. This is predictive engineering analytics. Begin with 1D simulations to optimize system performance based on requirements. Then, integrate multidiscipline 3D simulations to ensure structural integrity. A quiet cabin. A smooth takeoff. Improved aerodynamics. And more. Combine simulation, physical testing, and data analytics to explore new concepts. Go beyond verification. Simcenter, predictive engineering analytics to deliver innovation sooner and with more confidence than ever before, so your dream can take flight. That's ingenuity for life.
Now, this next video will illustrate a small portion of our capabilities for the industrial machinery segment. Keep in mind that this is just the tip of the iceberg. And this is an example of a place where Simcenter was used, and basically they wanted to optimize the energy efficiency of a ceramic kiln. Now, this paper basically focused on the combined 1D and CFD approach for the numerical analysis of the entire industrial ceramic kiln. And this kiln is simulated under actual operating conditions in order to improve the energy efficiency and thereby the fuel consumption as well, and also the pollutant emissions. A lumped and distributed parameter model of the entire system was constructed to simulate the performance of the kiln under actual operating conditions. The heat transfer coefficient for the 1D model are determined by means of the CFD analysis of the kiln modules. The lumped and distributed parameter model is constructed using Simcenter MSM code, and the CFD analysis is carried out in Simcenter Star CCM. The model of this whole kiln is able to predict accurately the temperature distribution along the different modules and the operation of many natural gas burners employed to provide the required thermal power. Furthermore, the temperature of these tiles is also simulated so that the quality of the final product can be addressed by the modeling. Numerical results are then validated against experimental measurements carried out on a real ceramic kiln during regular production operations, and a good agreement between the calculations and the experiments was obtained. So this is just one particular use case. I'll just highlight a couple more. I have a lot of use cases, so I won't go into detail on most of them. I've just handpicked a few which we'll go into, and the others I think we'll leave out. Now here, this slide shows what our customers are able to achieve when they transform their performance engineering process to engineer information. Now, in this case, it's a normal textile loom which has been around for decades, and how we can actually make it more energy efficient. Now, Picanol develops and manufactures high-tech weaving machines that are based on air jet and rapier technology. Now, for 75 years, Picanol has played a pioneering role in the weaving machine industry, and they've become a leading global player. But stringent market regulations and a tough competitive environment are compelling the production machinery industry to improve its machine design processes. Manufacturers actually need to deliver top-performing machines that comply with strict health and safety requirements. So innovations are being introduced faster all the time. These considerations make early-stage simulation almost compulsory to release innovative products faster and faster. This industry is also experiencing a recent shift in customer expectations. Now, the keys to success here were they implemented using MSIM and Simcenter 3D to be able to support the scalable optimization of energy flow, take into account energy efficiency and total cost of ownership as key performance criteria, optimize the machine design from the beginning of the design process. And the result was they designed the most energy efficient weaving looms on the market. They achieved product optimization very early in the design process. They balanced performance, durability, noise, vibration, all while minimizing energy consumption. And they also implemented advanced model-based system engineering. This is the Shenyang Machine Tool Company. It's a Chinese company which develops tools such as conventional lathes, CNC lathes, pipe threading lathes, and milling and boring machine centers. Now, analyzing and refining the machine structure used to be a long process of trial and error on expensive physical prototypes, but tight schedules and budgets no longer allow for this approach. Machine manufacturers are actually looking into various simulation technologies that can help them make the right decision early in the design process and deliver higher product quality on the first attempt. Now, this considerably reduces the total development cycle, saving time and cost. Now, Shenyang chose Simcenter as a simulation platform because it provides the most complete environment that covers the entire process from multi-domain system simulation, detailed 3D analysis, and test-based engineering. Now, one thing, this detailed 3D analysis, whatever 3D analysis you're doing, whether it's thermal, whether it's structural, whether it's vibration, whether it's multi-body dynamics, everything happens inside a single environment with a single model. You don't need to have multiple tools. You don't need to train your people on multiple different tools, it is very, very simple to leverage this. Now, so they have successfully used Simcenter to reduce the time they spend on simulation by 50%. This is just the simulation time they've reduced by 50%. Now, another reason they chose Simcenter is by looking to the future. Shenyang recognizes that machines are continuously incorporating much more and more electronics and controls, and they feel Simcenter gives them the best solution to simulate mechatronic systems through co-simulation of 1D control models with the 3D mechanical system. So basically, you're plugging your 3D simulation software, which is Simcenter 3D in this case, into your system modeling. So in the system modeling phase, you can actually validate the different control systems, see if it's working as expected. I'll give a brief insight into this. I didn't want to spend too much time on Simcenter because that way we will spend, I could go on for like 2-3 hours just on that. So I'll just highlight two particular products which I think are game changers. Then this is Agfa Graphics. Now, so these are basically printing press manufacturers. Now, the highly complex and huge machines that convert the aluminum rolls into printing plates are located all over the world. Limiting the vibrations in these machines is crucial to obtaining high quality printing plates and to avoid costly breakdown of the machines. The support team in the headquarters in Europe often needs to fly out to, for example, Brazil, to go and do vibration troubleshooting on those machines. Flying out with a current SCADAs with TestLab often leads to issues with customs, where the measurement system is blocked for several days and sometimes even weeks. This means a loss of valuable time and money due to unavailability of their sole measurement system. Now, initially, you may be thinking, okay, yeah, this is multiple locations. We're not that big yet. But think about 10 years down the line. You do want to grow into that size, that larger company where you have multiple locations. So at that time, these things are something that you need to, if you start working on it now, you'll be able to scale properly at that time. So now this means a loss of valuable time and money due to unavailability of their sole measurement system. Now, since several years, they were looking for a smaller system that would be easier to transport and a cheaper one than the already compact SCADAs mobile. So the introduction of Simcenter SCADAs XS, which is, let me just make a point. Yeah, so this is SCADAs XS. This is the entire data acquisition system. So this was the perfect answer to their needs. It was small, portable, price-wise, it was well positioned for the job. So convincing them to buy one was straightforward. No more risk of being blocked at customs. Just putting the Simcenter SCADAs in their laptop bag and jumping on the plane was what they've always been dreaming of. Next to being an extra small front end, the possibility of using the tablet made them think one step further. It allows the engineer to prepare the test setups back home, ship the system to the other end of the world with some basic instructions to the local operator. This operator can then do the time recordings of the vibration levels at different locations on the machine and simply ship back the unit or transfer the data over the internet. Now, back home, the engineer can analyze the data in detail using his Simcenter TestLab system and looking at the specific frequencies and transfer functions, thus identifying the root cause of the very high vibration levels which they were looking for in the first place. Now, again, we have a lot of material on this. There's a video on YouTube also, so you can look for Agfa Graphics Simcenter and you'll be directed to that. Now, one thing I should point out is, along with our very, very strong simulation suite, right? We touch every aspect, both electronics and mechanical. We are also the only vendor to offer test. Again, both mechanical and electronics. So whether it's you want to measure the vibrations, whether you want to measure torque, whether you want to measure, for electronics, you want to measure the conductivity, getting down to as much detail as when you put a chip on a PCB, you tend to use a paste to stick it to the PCB. Now, you can even characterize the conductivity of that thin layer of paste to get your most accurate thermal model. And that measurements can actually feed back into your simulation models, both for the thermal and for the mechanical measurements. It feeds back into the simulation system. It's called FE test correlation. And calibrates your simulation model to ensure that it's a high fidelity model now. Okay, now this is Mitsubishi Materials Corporation. Again, they improved 11% more cooling in the flow rate and 57% higher peak velocities, 40% better timeline extension. So here they're actually simulating to the end. Let's say you want a machine to last for 20 years. You can actually simulate to the entire drive cycle and see, are there going to be any issues coming in along the way? Again, here they've used Simcenter Flow EFD, which is a CAD package which plugs into any it's a CFD package which plugs into any CAD package, whether you're using CATIA, whether you're using Creo, whether you're using SolidWorks, NX. It plugs into all of them, and within that same CAD environment, so even the CAD engineers can do a basic CFD simulation. The process can be detailed by the simulation team, and they can do a basic validation. For an example, let's say there's a for the CAD engineer, a rear view mirror in a car might as well be a rectangle. I mean, because they're not really too bothered about drag and things like that. But the CFD engineers are very worried about that. So they can give a particular process, and until the drag coefficient is less than a particular value, they don't want those designs coming forward. So the CAD engineers themselves can do a certain amount of simulation to validate their designs. So this front loads the entire process, leads to better resource utilization. So there are it's a multi-pronged benefit of doing something like this. Next. Now, how do we do all this? So that brings us to Simcenter. Now, Simcenter is both. So our belief for the need to adopt this new approach of performance engineering in support of the holistic digital twin has led us to the creation of this portfolio called Simcenter. Now, Simcenter delivers the best-in-class CA simulation, system simulation, testing solutions, plus design exploration and analytics. And all these technologies are then managed in a PLM context using Teamcenter. And this supports the entire engineering and development of complex systems. Now, Simcenter basically, everything that's within it, you can cover fluids, thermals, it can cover electronics, it can cover physical testing, system simulation, mechanical simulations like structural, MBD, etc., vibration. And over and above this, you have things like, let's say, okay, again, like I mentioned earlier, Simcenter is very, very vast. If I need to talk about each individual tool for 2 minutes, it'll take more than 2.5 hours. So what I will do now is I will highlight the two most, I think they create the biggest difference, the most impact. So exploration and analytics is one of them. Then workflow automation also is built into one of them. Process and data management, again, is done with Teamcenter. Then we also have engineering services where our engineering services team is, they'll actually work with you to co-develop a particular product, or they will design they will do everything and do a technology transfer to you, or they will troubleshoot with your team. So there are multiple different approaches because there's no one size fits all approach in terms of engineering services. So they will do all that based on your requirements. And then dedicated support. This is something I must mention because Siemens has a support structure. It's not at all like anything that the support that you see for Airtel or anything where it's just a call center with people reading from a script. So these are all PhD people, and they are very, very skilled at what they do. Now, let's say as soon as you buy a license of Simcenter, you get a dedicated support engineer. Now, anytime you have any issue, you can get back to the dedicated support engineer. They will guide you through the entire thing. They will tell you what features apply to your process specifically. Let's say at some point you feel that there's a particular feature that you need, which is not there. This Simcenter has releases 3 times a year. So as soon as that is ready, it'll come out in the next release. Now, also, if let's say someone else has requested something and that comes into a new release, the DSE will, the dedicated support engineer will come and tell you like, okay, see, this is a new feature that will actually help your process, and this is how it's going to help. So they will come sit there with you on site, on-prem, and they will actually show you how to leverage that to get the most bang for your buck, get the most out of your investment. Now, in order to take advantage of the opportunities afforded by digitalization and the digital twin technologies, companies need to mature their capabilities in simulation and test. Now, drawing on our years of experience helping the market-leading companies in this space, we have identified 4 key dimensions along which our organization capabilities should evolve and mature their capabilities. One of the first requirements our customers ask for is the ability to predict and measure behavior or performance in the best possible way. Now, this means capturing all the complexity, be it the geometry, the physics, or the usage environment, all of which can influence performance. Greater accuracy leads to greater confidence in the predictions and therefore in the decisions. Like, let's say, what this basically means is, let's say, if I'm looking only at vibrational aspect. Now, let's say the surrounding temperature increases. That may change the vibration parameters. So I need to consider all these different things in one environment. Now, that is one thing that Simcenter facilitates. Then to truly gain an advantage from investments in modeling complexity, companies need to leverage those models to run experiments. An increase in complexity also means an increase in the degrees of freedom available for adjustment. Through a systematic and intelligent exploration of the design space, they start to gain tremendous value from the models. So investments in design exploration are critical. Again, this is one of those tools that I was talking about earlier, which I feel makes a huge impact. So I'll come to that in a couple of slides. And then going faster with development, as mentioned earlier, the traditional pressures of time, cost, quality still apply, even though the complexity is increasing. And increasing complexity can actually slow down the organization's ability to make the right decisions. Therefore, companies need to find a way to go faster despite the complexity that they work with. This can include investment in process capture, workflow automation, cloud, or HPC, and other such investments. And through this all, you need to stay integrated. And as a product development has become increasingly complex, there are more opportunities for misalignment between teams. Development in different functional areas happens simultaneously. An optimal decision in one area could prove to be suboptimal for another and cause delays in development or worse. For example, let's say to stiffen something, I put a beam, which gives me the required stiffness, torsional rigidity, but it's a nightmare for the CFD engineer. So you need to have the multi-attribute balancing. So that is something that companies need to mature their use of solutions that can help the team stay integrated across all the different relevant functions. Now, the use of Simcenter delivers a number of benefits to the customers, including the ability to design and engineer better products, gain earlier insights on performance, accelerate innovation, which helps them gain market share and achieve greater productivity, whether it's at the individual, team, or organizational levels. So we ensure our customers derive the greatest benefits from their investment in Simcenter. This is achieved in many ways, such as our open philosophy that enables Simcenter to work within a broader ecosystem. So you can bring in tools from models, or let's say 3D model from you have another CAD package. We don't insist that you have to use our own CAD package. You can bring it in from there and you can use it in Simcenter. Then, as I mentioned, the unique support model, then our expertise with the both pre-sales and engineering services, and then our investments in continuously growing this portfolio. Again, something that I will touch upon a little bit later, and how we can partner with our customers on technology development. As a key part of the accelerator portfolio, which is Siemens' larger thing for enterprise digitalization, Simcenter delivers even greater value for our customers' business by integrating simulation and test into the broader context of development digitalization. Now here, let's just quickly cover system simulation. There's a reason I'm actually going into this. So we can actually use this to handle all the other simulations also. In each time step, let's say the CFD, we could have MBD. Okay, like in case of a wing. So a wing that can be moved for a plane. So then at every movement of the wing, the CFD changes. So then that is also done. So all these things are plugged in, and the system simulation is the overall manager of the entire process. So basically, it allows rapid creation of these physics-based product models with all the aspects, mostly using predefined libraries. So we have very, very vast libraries of industry-validated models. So now these are engineers can actually couple these parametric descriptions of these subsystems without actually requiring geometric details, which is why it's 1D. So making it very suitable for early balancing of multiple design attributes during the concept phase. Now, during later stages, these models can then be gradually refined as more details become available. So like initially, it's just a drag and drop model from the library, a parameterized model. Later, you can probably bring in your 3D model with the simulation. You can plug that in. Then once you prototype, you can bring in the test data. Then once you actually have the first prototype, the physical thing, then you can actually even plug that in. So at every stage, you're actually validating that the entire system works cohesively. And this ensures that there is absolutely no rework required. You will get your designs 100% right from the first time onwards. Okay, there's no multiple, like normally what happens is design, manufacture, test. Okay, there's some issue, go back to design, manufacture, test. That it's a very long iterative process. It's expensive, it takes time, it uses a lot of manpower. You can eliminate all that, get everything right the first time, and this will be a main architect in doing that. Now, its unique capacity to run in real time extends the application of the solution to even verification and validation processes, often in co-simulation scenarios, and also to control development, like I mentioned earlier. So basically, this can be used through each phase of the product development. The libraries are there. Initially, let's say you're developing a system of a piping network, and you want to know what size pump I need. Now, normally we're just using a rule of thumb. We just give a factor of safety, and we tend to over-engineer because we, at any case, in any situation, we don't want to under commit on the size of the pump. So then, okay, let's give it significantly higher. So that's terribly over-engineered. It's really unnecessary, and the operating cost over time is going to be much higher than necessary. So you need to size those pumps initially. Now, all those things can be done at the initial stage, at the concept stage itself. Before you've even gone into your first 3D design, you can do it initially. And then performance balancing, as I mentioned earlier, and all the different aspects, you'll need to ensure all these different attributes of different systems. Like, let's say, okay, I want to put like a very heavy, a very bright headlight, or I want to, a lot of electrical systems are going to be there, like the AC and stuff like that. But will my battery be able to handle that? All these validations can be done upfront. And then again, like I mentioned, the controls verification, then plugging in the actual hardware into the hardware, and in this case it's hardware in loop. You can also have model in loop, you can have software in loop. So there's operator in loop, the multiple different ways, you can use it to simulate the thing. Now, in this particular case, we don't actually have a car. We just know that, okay, this is the geometric dimensions of the back part of it. So everything is separate here. The steering, the wheels, the road, everything has been parameterized. Now, it's actually a video. Yeah. So the video is playing. Now, we want to see how it operates under crosswinds. So now you can see. So here you can actually validate things like the ESP control system, like the electronic stability programs, which slow down one wheel to ensure that, let's say, one wheel has gone up in the air, slow down the other wheel to ensure that this wheel comes back down. So all those things can be validated using this process. This is just one example. Now, I'll just show you an example. So basically, you're validating the control system. It's just a basic robot, which is going to do like a jump and then walk in you want it to walk in a straight line. Now you have to sync the movement of all these four legs to ensure that it walks in a straight line. But we'll validate, we'll do a quick simulation of the control algorithm and see if it's operating as expected.
In this example, we want to show you how system simulation with Simcenter AMISIM can improve your robot development process. Therefore, in a first step, the simulation model of an individual leg is developed. It consists of the leg made up of components from the 3D mechanical library, 3 DC motors to drive the hip, thigh and lower leg joints, and 3 controllers to control the individual joint angles. With AMISIM's 3D assembly tool, it is easy to visualize and position the different body parts, as shown here for the thigh, which is connected to the hip and lower leg joint. The same tool also allows us to animate the leg movement from different perspectives. Once we are satisfied with the leg movement, we can continue with step 2, the body assembly and control development. AMISIM allows us to speed up this process by reusing the leg model 4 times and connecting it to a body. On the bottom of the model, you can see the control laws for the leg movement to perform different body movements. In order to visualize the robot movement, we can add cameras in the animation space and also make use of a split screen feature. Let's perform a 20-second long simulation run and see how our robot behaves. First, we check if the controllers behave as required and if the set values are met. In the animation, we can see that the robot initially performs 2 push-up movements before it starts walking. Since it's not really walking in a straight line, we can now start to optimize our control laws. For further information, please get in touch with us.
So that was an example of how you validate the control system. Now, one thing there, I'm not sure if you noticed, but that simulation that happened was actually in real time. It's not like we've sped up the video or anything like that. It actually, even for a large thing like an aircraft, so people have actually, so I think it was Airbus, they've used this to actually simulate the entire power on of an aircraft before they even went to the first 3D model. And then once they had all the parameters, they knew everything was working correctly, they were able to do it very, very fast. I mean, they could do it with just basically they flew it before they built it. And what that led to is normally aircraft can take 9 to 10 years for a single aircraft. Here, in 6.5 years, they had 3 different variants out of the same aircraft, which is unheard of. And now, yeah, obviously now they are completely into this. So, and this helps with, see, like aircraft power on, aircraft trajectory takeoff. They're all criteria, all tests which are very significant to their getting an aircraft certified. So before they even went into their first 3D model, they ensured that everything was working to make sure that these certifications, whatever criteria is there, they'll be met: rejected takeoff or aircraft power on. So once both those were done in one shot, they just made everything and everything was working as expected. Got the certification very, very fast. Now, the other thing I was mentioning, and this I think is a game changer, exploration and analytics. Now, normally when we do a simulation, we have an objective X. Now we modify certain design variables to reach that objective X. Now we just keep iterating through that. But I mean, it's a very tedious process. It's similar to this Rangi-Kutta method that we had in engineering. You just keep substituting with new values and just see which one will bring you the closest. But there are also multiple different variables, so you don't know which one is going to bring you closer, which one's going to take you further away. All these things have to be balanced. So here is where we bring in HEEDS. Now HEEDS, one thing, it automates your entire process. So let's say you have CAD, it'll take your designs. It'll you can bring in, let's say, if you have for CFD one tool, for acoustics another tool, for electromagnetics another tool, for thermal maybe another tool. So all these things, it can actually integrate it, so it automates the entire process. Now it can also execute on multiple cores. So it could, you could do it on a laptop. If you have a subscription to, let's say, AWS or Azure and unlimited number of cores, it can also scale to that. And like I mentioned, there'll be multiple variables, right? Now we have a proprietary algorithm called the Sherpa algorithm, which in the shortest possible time, it will decide which is the best balance of attributes. Now let's say I mentioned objective X. Now what do we have? Objectives X1, X2, X3. Like one is for temperature, one is for NVH. So all these things have to be balanced to get the best possible result. So this thing will actually give you the best possible result in the least amount of time, and it has been benchmarked against other algorithms. There are other tools in the market, similar things which are tougher to use. The main thing of Siemens tools is that they are easy to use and they are fast, and without sacrificing any accuracy, as can be attested by so we are ISRO, DRDO, SpaceX, Tesla. They're all customers of us, so Blue Origins. So in terms of accuracy, there is absolutely no sacrifice, but it's very easy to use, and it's also quick in your entire thing. Now, in this particular case, and also insight and discovery in the sense that different variables, how they relate to each other, not just how they impact the eventual objective, but how they design sensitivity, the variable sensitivities to each other. So all these things can be mapped. So if you look at this thing, it's actually the design sensitivity mapped. Now, and also here you can specify certain constraints that you have. So you can specify the objectives, you can specify the variables that you want modified. You can specify whatever constraints you have, and it'll try doing everything without violating those constraints. It'll give you the best match to X while varying the design variables to reach your design objectives X1, X2, X3. Now, in this one, you can see blue and red. The red ones are the ones that the iterations that violate the constraints, so it won't even try those. The blue ones are the ones which are within the constraints. So all these are different ways to read the different aspects of this, the output of HEEDS. Now, in this particular case, it's being used for this. This is a PCB. Now, there are certain vents. There are two vents here. Now, we want to optimize the position of the vents and position of the fan. And the other variables are the size the geometry, and the number of pins. Okay, to ensure that there's least temperature on the PCB. Right now, you see the temperature is very high because of the red contours. So now let's see how it gets optimized. And this entire thing is automated. There's no user interaction at all. So you can see it's changing the positions of the vents, position of the fan, the different geometries, the number, size, shape. So this is the most thing. So now there's hardly any red. There's slight traces of it here, but that's about it. So when you're balancing multiple, maybe there would have been one with less temperature, but there may be other constraints that were given, which for this particular requirements that were given, this is the best possible outcome. Now, as I was mentioning earlier, you will never be left alone, to steal the line from Liverpool. But we've spent $5.2 billion just on acquiring different companies. Now, we already had a solid portfolio with Simcenter, and a lot of you may know Ideas. We had NXCAE in between, and then we kind of bolstered it. We recently acquired Mentor Graphics for the basically our electronics portfolio, electronic simulation. So all these things, so we're continuously bridging any gaps that we have, any place that our customers say, okay, we need this particular tool. Immediately, we kind of try to make an acquisition to, or we try growing it organically, but that takes time. So what I'm trying to say is other companies, they tend to make promises, and then a couple of years down the line, they may say, okay, no, this is not under development anymore. Here we are completely dedicated to this entire Simcenter portfolio. This happens to be our vertical happens to be the fastest growing vertical of Siemens worldwide. So Siemens is actually increasing the headcount significantly in our organization. There is going to be a continued focus on this for a very, very long time. So in terms of industrial software, we are number one in the market. We have lots of patents. We have the revenue is very high. Most of the Fortune 500 are our customers. So basically, you will never be left alone if you get on board with Siemens as a customer. Now, largely, these were the areas that we thought will be important in the for Simcenter investments. I won't spend too much time on this slide in the interest of time. Now, for industrial machinery, we felt these are the different areas which will be the most significant. The performance, the throughput, production rate, precision and accuracy, reliability, the durability, maintenance, the electromagnetics, the noise and vibration, the thermal aspects, smarter machines, the controls, flexibility, operator assistance, predictive maintenance, Internet of Things, and efficiency is the energy used, the tool wear, the waste of raw material, everything to optimize all that. Now, let's go into these in a little bit more detail. As I mentioned, I have a lot of case studies, so I'll just cursorily glance over all of them. If you feel that you are interested in any particular case study, or let's say it's very similar to what you do, you can I had showcased my coordinates at the beginning of the presentation. I'll also do that at the end of the presentation, and you can get back to me and let me know if you have any further queries, any particular case study you want more information. A lot of it is also available on Google, and not on Google, sorry, on our website. So you can just Google for it. It might show up on YouTube. It might show up on our website. So all this information is available. Of course, there are if there are issues where you don't want your data to be seen by anyone else, you don't want anyone to know what you're doing. Similar to what we're doing with the Blue Origins or SpaceX, we have a non-disclosure agreement with them, so we don't show any of what we're doing with them or anything like that. It's we don't do that anyway. So we can do that with you also if that's a concern. Now, first, let's go into the performance. This is a video case study. I'll skip it again in the interest of time.
My name is Peter Zawadink.
This is for the packing systems, the nozzle flow rate optimizing this. This is for extrusion. Then we go to reliability. Again, a video case study, which I will skip. This is again high-speed milling machines for the furniture industry, and better controllability, increasing the production efficiency thanks to the source transfer receiver, which is basically a way to tackle noise, vibration, and harshness issues. So that way they manage to reduce time and cost. This is with Homag. Again, Picanol, this is again not the same thing that we discussed earlier. This is a different thing that they're a big customer of ours. So then again, electromagnetic modeling, we have both low frequency and high frequency electromagnetics available within Simcenter. So within the same environment where you're doing everything else, you can also do electromagnetic modeling. And it has material databases, anything that you require. Again, EMI/EMC is a big issue in Industry 4.0 with all the different kinds of things. So then you can actually use high frequency electromagnetics to decide the location of sensors in IoT equipment, so that there is no conflict. This again is smarter machines. So this is a bottle filling plant, a bottling thing. So they reduce the number of prototypes by more than 20%, which, I mean, for a company which is making a company which is making bottles. So this is reducing the number of prototypes by 20% is a significant amount reduction in the usage of raw material, time, every cost. I mean, manpower, everything. So it's a no-brainer. They increase their design accuracy and maintenance also. Further down the line, they saved so much time just on maintenance. Then coming to efficiency. Again, video case study, which I will skip. Again, Picanol, like I said, they're a big customer, so they managed to reduce the NVH, they reduced the fatigue, they increased the fatigue life. They reduced at least one full prototype iteration step, which again reduces development duration, cost, time, everything. And engineering, as I mentioned, the engineering services I mentioned earlier, they'll cover multiple different fields of simulation. They'll do the troubleshooting of whatever processes you have. They will co-develop with you. They will do it themselves and do the technology transfer, and they can work with your methods team and kind of transform your engineering process if that's what you require. So as we discussed earlier, in terms of realism, continuity, and exploration, Simcenter gives you all of this, which helps you with more innovative solutions. It's faster to market, better products, lower development costs, and increase market agility. Now, so how do we make this happen? So we've done this many times with many companies in various situations. And the best approach is to sit down together and build a roadmap, starting with the end in mind. Each roadmap is different, but they follow a similar recipe for success. Now, we begin by identifying your realistic near-term innovation goals and then plan how to get there. Okay. Now, the first step is to identify a good candidate for your first project. What makes a good candidate? We look at things like impact on your business, resources available, likelihood to get a quick first success so you can see return on your investment. Then we will together look at your goals. And in other words, what is it you're trying to improve and the constraints, and then guide you as you build that first virtual prototype. We use a quick start approach that typically includes a combination of acquiring the software, training, best practices, and mentoring from your dedicated support engineer to make sure you get moving quickly. Then you'll move into the phase where you are exploring the design space and use analytics to improve in your design, taking into account your design budget and things like time, compute resources available, etc. So this way you achieve better performing designs. Getting to this first success quickly is important, and it allows you to see and communicate what your return on investment will be. From there, it's just time to expand your engineering innovation strategy to other projects and basically eventually reach your innovation goal of the organization. So in summary, to master this complexity, you need solutions that will help drive innovation and enable collaboration by breaking down the silos between the different simulation aspects between CAD and manufacturing and simulation, and weave a digital thread across all development activities with a comprehensive portfolio that combines simulation and test along with engineering services and dedicated support. And it's backed by the strength of Siemens and Accelerator. Siemens offers this unique DNA to help you in your digital journey. So that is all I have for today. Again, these are my coordinates. If you would like any further information on anything, do feel free to get back to me. I will be glad to assist you, give you more information. If you would like to Google and find out more details about it, there's a lot of information also available on YouTube and our website. So you can go through that as well. Thank you, everyone. Over to you, Vrishali.
Thank you so much. Thank you so much, Sushil. It was indeed a very in-depth presentation, and you really took us through how we can, innovate, how we can reach faster to the market, how we can build agility in our processes. I just want to ask one quick question. Most of the Indian companies are still in the transformation phase. They're still using the legacy systems. And how do you think that Simcenter or this technology can fit into uh, when the companies are in the nascent stage of transformation?
Right. So that's actually a good question because see, like if we tell everyone, a company like that, okay, you have to do digitalization, it becomes difficult, right? So we'll take the method of crawl, walk, run. So first we will start, let's say, in one particular area, maybe simulation or let's say CAD. Then slowly build on that to other areas until the entire organization has been moved on to a digital twin completely.
Okay. And also, just a follow up to it, if we are in the second phase, we have done the designing phase and we are in the second phase, is the right time to include digital twin or Simcenter into the next process?
Right. So ideally, so when you have a particular design, you need to validate that design. So that's where the simulation comes in, rather than going and creating a physical prototype, then testing it, then okay, it's not working, come back and redo my design. You can do that simulation, do that iterative process right there itself. So technically, simulation would be hand in glove with your design phase.
Okay. Thank you so much, Sushil. If anyone has any further questions, Sushil Samuel's coordinates are already on the screen. Please take a screenshot and you can connect with him directly. And as he said, plan your roadmap with a goal, and Siemens is here to help you out. Thank you. Thank you so much, Sushil.
Yeah, thank you, everyone. Stay safe.